Hello everyone! In this video we will continue to examine topic 1.3 vectors and scalars, and in particular look at some applications of adding vectors. Alright, so as discussed, any sort of vector quantities add like arrows do. That is, how do arrows add? Well, they add tip to tail graphically. Notice that a plus b added like this, tip to tail, is the same as b plus a, added tip to tail. This is possible in part because two vectors with the same magnitude and direction are the same vector. So it's not that this blue arrow is different from this blue arrow, it's just represented as starting from a different spot. So they don't have fixed locations. All right, so given that, we've got a couple of questions here that you may want to take a look at that demonstrate how you might use a ruler to scale and a protractor to find a resultant vector, adding it tip to tail. But we're going to discuss sort of another way to do it. Now, ultimately, this will be equivalent. But we're going to use trigonometry to find exact values without pulling out a ruler and a protractor, which can be convenient at times. So we're going to start by first considering how two vectors that are exactly at right angles are going to add. So let's say you have vector A pointed up and vector B pointed to the right. Now we're going to add them up and get A plus B equals C. So we add vector A here to vector B, and we get a resultant vector C along the diagonal, forming the hypotenuse of this particular triangle of angle theta. Notice we could as well specify the direction of vector C if we wanted to, with reference to a different angle, the one relative to the horizontal there, for example. But as long as you have a diagram, then you can specify the direction with the angle and just give the angle. If you don't have a diagram, you have to describe what angle it is exactly that you're talking about. All right, so we find A plus B, and all of you hopefully can recall the relationship between the length of A, the length of B, and the length of C, which is simply the Pythagorean theorem. So if you take the value of A squared, add the value of B squared, you will get the value of C squared. This is written like this using norm vector notation. So this is sort of a fancy way to write it, keeping in mind that vector B is a vector, so we need to take the magnitude of that vector and then we're squaring it. Most people will simply drop both the vector hat and the norm sign and just write C squared equals A squared plus B squared. Notice that we will also want to specify the angle or find the angle, which can be found using simple right triangle trigonometry. So your tangent here is your opposite over your adjacent. And so tan of theta is equal to B divided by A, okay? And this is when the vectors are at exactly right angles. You can practice this skill using this practice question shown here.